Good morning everyone. Today we will discuss about regression. Regression means we are taking from the correlation only. So regression means we are telling about a mathematical relationship between two variables. In a mathematical notation we are giving that is known as a regression. Topics to be covered in this lecture is applications, regression equations and regression coefficient and properties of regression. First application is here the mathematical relationship between two variables I am telling. See this picture here, depending upon x values. If you take the place 100 meters square, the house size will be small. If you take it is lies between 100 to 200, it will be medium size. And if you take the value more than 200 meters square, we get a large size of a house. So depending upon our x values, y values will be changed. So that is the one of the application for regression. Not only this one, in machine learning mainly we are using this regression. So that means we are giving the inputs to the data, so we will predict the output. So using machine learning, see the first example, I am using BP mission here. We are giving the input, so it will predict the output. So in that case it will store one equation in that mission and it will give the output for us, same as it is in a sugar levels mission also, same as it is. If you give the sample, that means if you give the blood sample, so we get a output using the regression analysis. So these two are we are designing using the machine learning. So in machine learning all the cases using the regression analysis only we can predict the output, right? So now methods of studying regression. In regression we are having two methods. One is known as graphical, another one is known as a algebraically we can find. In graphical method again we are having freehand curve, another one is the least squares method. In algebraically we are having least squares method, deviation method for arithmetic mean, and another method is deviation method from assumed mean. So using all these methods we can find a regression. Here I am using algebraically using least squares method, I am finding the regression. So the lines of regression y on x and x on y we are taking. Here one variable is completely depending upon another variable. Y on x regression line means here y is a depending variable, x is an independent variable. So y is completely depending upon x. So for this the mathematical relation can be written as y minus y bar is equal to r into sigma y by sigma x into x minus x bar. So I told already regression is we are taking from the correlation only. See here y bar is the y values mean and x bar is the x values mean and sigma y is the standard deviation of y values, sigma x is the standard deviation of x values. But here r is known as the correlation quotient. If you want to find out the regression line or regression quotient, in always we are using the correlation coefficient only. The correlation coefficient r can be defined as covariance of xy by sigma x into sigma y. Next, regression line x on y. So here we are taking x is a depending variable, y is an independent variable, x is depending upon y. Now the mathematical relation can be written as x minus x bar equal to r into sigma x by sigma y into y minus y bar. Again x bar and y bar are mean of x and y, sigma x and sigma y are standard deviation of given data x and y, and r is known as the correlation quotient. The correlation quotient r can be defined as covariance of xy by sigma x into sigma y. So these two are we are using here. So next we are having This is the R value, covariance of xy by sigma x into sigma y, which is known as a correlation coefficient. And examples of regression. So I am taking one of the example here. See here, they are showing one equation, y is equal to b naught plus b1 x. So this line is there giving straight line. Given x values, the y values are we are getting here. For this we draw the straight line. Depending upon x values, y values are we are getting. Here y is a dependent variable, x is an independent variable. So one variable is completely depending upon another variable. We are representing in terms of a mathematical equation. Right? So next, regression quotient. So regression quotient means in y on x, the independent variable coefficient is known as a regression quotient of y on x line. That can be represented by byx. In byx, that means y on x line, x quotient is r into sigma y by sigma x. Same as it is regression quotient x on y. X is the depending variable, y is the independent variable. Now in x on y line, y quotient is we are taking as the regression quotient, and it is represented by bxy r into sigma x by sigma y. Right? So next we are seeing some properties of regression analysis. Regression lines always through the points x bar and y bar, the mean of x and y values. And sometimes they are giving the regression lines. Using that regression lines, we want to find out a correlation quotient. So in that case, we are using this property r is equal to root over byx into bxy. Byx means which is known as a y on x regression quotient. bxy is the x on y regression quotient. So we are taking the root over and we are multiplying these two values, we get a correlation quotient. Sometimes they are giving like this also. byx is less than 1, compulsory bxy is greater than 1 only. And the angle between two regression lines can be written as tan theta is equal to 1 minus r square by r into sigma x into sigma y by sigma x square plus sigma y square. If they are given the two lines, if you want to find out the angle between two lines, using this formula we can find directly. Next, if r equal to 0, two regression lines are perpendicular, and if r is equal to either plus 1 or a minus 1, the two regression lines are parallel or coincide. Right? So these are the some of the properties of regression lines. Thank you.